Okay, good afternoon, guys. Today we will be discussing about routing concept. That is module 14. Um, this is a very, very important module. I mean, we will talk about the different types of routing. So let's look at um, the topics. We have path determination, packet forwarding, basic router configuration review, IP routing table, and static and dynamic routing. It's quite a wide one, but it's very, very important. How does routers determine the path? There are two categories or two main functions of a router. Is routers will determine a particular path to a particular destination. It says when a router receives a packet, it will determine which interface the router will use to forward that packet to a particular destination. This is known as routing. In essence, routing is sending packets from one network to another network. The router is a layer 3 device, okay? And one of its functions is to send packets from one network to another network, okay? It says the interface that the router uses to forward the packet may be the final destination, or it may be a network connected to another router that it used to reach the destination. Okay, this can be a complex network or it can be a simple network. Suppose it's a very simple network. Maybe the interface that the router forward the packet is the final destination. Or it can also be that that interface is not the final destination. The final destination is also connected to another route. So the primary function of the router is to select the best path to forward the information. There could be multiple paths to reach to a particular destination, but the primary function of the router is to choose which one of the paths is the best path. Okay, just like if you are at CMIT, at Brusubi, and you want to go to Westfield, you know there are multiple paths that you could go to Westfield. You could go via traffic light. Some could come up to Manjai, get to the Kisel Junction. Someone to take the Bakote Highway. Someone to take even the airport route. So these are all possible paths that can lead you to the same destination. But the function of the router is to choose which one of the paths is the best one. So this is a diagram that depicts the function of the router. Okay. This is a diagram that depicts the function of a router. If you look at, there is a demonstration here that the router using its IP routing table. If you remember when we discussed about switches, we said switches maintain a table called CAM table or MAC address table. So routers will also maintain a table called routing table. So that routing table is going to contain information of all the networks that your router have learned. So you can see here, if you type the command show IP route, you will see the list of all the networks that you know, if you look at it. So there are different letters that are used to depict. If you see C in front of a network address, that means that network is directly connected to that router. But if you see S, S means that network is learned by the router using static means. You will get to know what static route is. Okay. So best path equals longest merge. The best path in the routing table is also known as the longest merge. The routing table contains route entries consisting of prefixes and prefix length. Like I told you, routing table contains information of all the networks that your router have lab. When we do lab, we will do one lab on this. You will see this in practice. So IPv4 longest match example. If you look at, this is an IP address 172.16.0.10. This is an example of an IP address. But this IP address is in a decimal notation. So the binary notation is represented as this. But there must be also a prefix length. You can see prefix length or subnet mask. This prefix length is, this one is /12, this one is /18, and this one is /26. So when you were doing subnetting, you have been taught about these prefix notations. So the slash means the subnet mask information, okay? This one is the IPv6 longest match example. It's the same information. This is an example of an IPv6 address, and this is the subnet mask information /40, /48, and /64. How do we build a routing table? Like I told you, routing table is a table that has entries of networks that your router is able to learn. That either the network is directly connected to the router, or it is statically configured, or is dynamically learned. You can see these are the three. How do you build the routing table? Directly connected networks are added to the routing table by the local interface that is configured. By default, routers, they know about directly connected networks. So the moment an interface is connected to the router and it is up and running, that network address is added to the routing table directly, okay? So you also have, apart from directly connected networks, you have remote networks. Remote networks means networks that are not connected physically or directly to the router. There are two ways routers can learn about remote network. First one is static routes, and the second one is dynamic route. Static routes added to the routing table when a route is manually configured. In essence, static routing, you have to manually inform the router about all the remote networks. This is very cumbersome and tedious. It is not scalable. It doesn't scale well in a very large network. Maybe in a small network, you can do this. Dynamic routing protocol added to the routing table by using routing protocols. Different routing protocols you will see here, okay? You also have default route. You will see default route that is also manually configuring the default route. You have different ways of packet forwarding that we will look at. Packet forwarding processing decisions, okay? The packet forwarding processing, there are different ways that routers will forward packets, okay? Here you have, this is a frame at a data link layer. You can see the data link header. The data link header is going to contain the source and destination MAC address, okay? And you have the destination and source IP address will also be here. So the data link frame with an encapsulation packets arrive at an egress. Egress interface means an incoming interface. The router is going to examine, is going to open that packet and examine the destination IP address on the packet header and consult. The moment the router opened the packet header and check and found the destination IP address, the router is going to consult its routing table, okay? The router is going to consult its routing table. The router finds the longest match prefix in the routing table. The router encapsulates the packet in a data link frame and forward it out to the egress. The moment the match is found in the routing table, the router is going to encapsulate the packet and send it to an exit or interfaces. However, if there is no match in the routing table, the packet is dropped. If the destination address is not matched, is not known, the packet is dropped. Okay? So we have the packet forwarding decision still continuation. Forward a packet to a device on a directly connected network. If the device is directly connected, it is easy, so forward a packet to that device. Forwarding packets still after a router has decided, or after a router has determined the best path, it could do the following: forward the packet to the next hop router. Yes. If the router has determined the best path, what the router might do is to forward the packet to the next hop. The next hop router means the next closest router. That means next hop. Okay. The next router close to the router, the router is going to forward that packet to it. That is one thing the router could do. Another thing is the router could drop the packet if no match is found in the routing table. We've said this. If no match is found in the routing table, the router could drop the packet. Okay? All right. End-to-end packet forwarding. The primary responsibility of packet forwarding function is to encapsulate the packet in an appropriate data link frame for outgoing interfaces. Sorry. Huh? For example, data link frame format for serial could be point-to-point. Point-to-point is a WAN technology, and high-level data link HDLC protocol is also a WAN technology. Packet forwarding mechanism. There are 3 packet forwarding mechanisms with Cisco. You have process switching, fast switching, and Cisco Express forwarding. We'll look at them individually. In process switching is an older form of packet forwarding mechanism, but it's still available in Cisco routers. What happened in process switching? When a packet arrives on an interface, it is forwarded to the control plane where the CPU matches the destination address with an entry in the routing table and then forwarded to the exit interface. It is important to understand that router does this for every packet. So the problem here is router will do this process for every packet, no matter the number of times that packet arrives on that route. You understand? If any packet arrives, the router is going to forward that packet to the control plane and is going to consult the routing table as to where to send this packet to the exit interface. So it doesn't matter n number of times, even if the packet comes right now and another one, okay, even another packet comes and another one comes right now, sorry guys. So this router is going to do this n number of times. So that is the problem. The other one is called fast switching. Fast switching is also another old packet forwarding mechanism. And the fast switching uses fast switching cache. What it says here, in the fast switching, there is a cache or a small storage in the router, where if a packet comes for the first time and it is processed, that information about that destination is going to be stored in that cache or in that storage. So that next time, if another packet comes with the same information, it is not going to be sent to the control plane. That information is going to be fetched from the cache. So this one is a little bit faster, or is better than, the process switching. So then later, the final one is called Cisco Express forwarding. Is the recent one and default on Cisco IOS. the Cisco Express forwarding will build a forwarding information base, FIB, and an adjacency table. Apart from the routing table, it's going to build a FIB table. The table entries are not packet triggered like fast switching, but they are chain triggered. That means if that table is built, nothing is going to happen unless and until if a change happens. If a change happens, then the table is going to change its entries. Such as when something changes in the network, let's say for instance, an information is stored in that table, but a topology has changed. When a topology has changed, that entry on the FIB or the adjacency table is also going to change. Basic router configuration review. This is an example of a router. We have two routers connected by a serial cable, and each of them are connected by switches and then to computers. So we will look at how do we configure router interfaces. These are the commands here. Just like switches, you have the same prompt. From the user execute mode, you type enable, then you type global configuration. This is the command to change the host name of the router, host name R1. You can also, the same thing we have done, you can also configure enable secret password with enable secret class. Class is the password. You can also configure the line console, the console password, okay? And the telnet password, this is how you configure the telnet password. So it's the same information, right? I'll do a small lab on this and share with you. So these are the verification commands. The verification commands are very, very useful. To check all the interfaces and their status, you have to issue this command, show IP interface brief. So running configuration on a particular interface, show interfaces, show IP interfaces, and show IP route. And you can also use ping commands to test connectivity. The filter command outputs. Mainly, you use filter just to be able to, select what you want to see on your screen when you are running the show commands. Some router configurations, some core router configuration can go multiple pages, and you are looking for a specific information. You don't want to go through all those pages. It's going to be very difficult for you. So you can use the filter command. That's the pipe command you're seeing here. Pipe. You can use the filter command, to tailor-made or to essentially pick what you want to see on your screen. You don't want to see, like if you type show running configuration, you will see a whole hell lot of commands. And you don't want to look at all those things. You only want to check specifically your DHCP configuration. So you can use the filter command so that only the DHCP configuration will appear on your screen. Okay? I hope it's very clear. So IP routing table, like I told you, switches maintain MAC table or CAM table, content addressable memory. In routing, routers maintain a routing table. We also talk about how a router build those routing table is either directly connected networks, static route, or dynamic route. These are the three. So like the alphabets I was talking about, you have different alphabets in front of network entries on the routing table. Each of those alphabets have a meaning. If you see L in front of a network, that means that address is locally connected to the router's interface. And that means if you see C, that means it is a directly connected network. L means address, an IP address that is assigned to a router's interface. But if you see C, C means directly connected networks. If you see S, S means it's a static route. And O identifies dynamically LAN networks from another router using OSPF. We'll talk about OSPF. OSPF is a routing protocol, it's a dynamic routing protocol it stands for open shortest path first. If you see star, that means the route is candidate for default route. Routing table principles. There are 3 routing table principles. First is every router makes its decision alone based on the information it has on its own routing table. Every router will make its own independent decision based on the information that is in its routing table. Second, the information in the routing table of one router does not necessarily match the routing table of another router. The content of routing table B's of router A is different from, might be different from the content of router B's routing table. Routing information about a path does not provide return routing information. That means the sending path will not provide a return information for the same route. So this will be an example of a routing table. This is how it looks. You can see those alphabets here. O. You can see the network here. You have some metrics information here and where it lands and the interface it lands. This is for IPv4, okay, and this one is for IPv6. So these figures here, this is the administrative distance and the metrics calculation. You can see them here. First, number 1 is route source. Number 2 is the destination network. 3 is the administrative distance. 4 is the net metrics. 5th is the next hop and the route timestamp and the exit interface. Like I told you, directly connected networks are represented by C. C is for directly connected networks. L is for directly connected interfaces. We move on to static routes. Like I said before, static routes, you have to manually inform or configure all the networks so that the router will be able to know them. The router cannot learn them dynamically. It is hard coding, it's manual routing. It is error prone, like I told you, and it's not advantageous when you're managing a large network. Mainly, this is for small networks, okay? Static routes in the routing table, if you look at this, this is the command to configure static route. The command starts from IP route, the destination network, the subnet mask information, and the next hop address. So we'll do this. This is for IPv4. For IPv6, it's the same thing. The only difference is you replace IP with IPv6, route, remote network, and the next hop. Okay. Dynamic routing protocol. Dynamic routing protocols use different types of routing protocols. Previously, we looked at a lot of them, but I don't know, maybe the Cisco new version, they have removed some of them now. But we will see which ones are available. Okay, so this is like we have seen. So IP route is a command used to check the content of the routing table. And in the routing table entries, if you find O in front, that means it's a dynamic route and it is learned using OSPF. Okay. So we move on to default route. Default route, in essence, default route is represented by this 0.0.0.0/0. For IPv4, for IPv6 is ::/0. That means what default route means is you are telling the router that if you come across any packet that you don't know the destination or you don't have an entry of its destination in my routing table, send it to a particular exit interface. Is it clear? That is the simplest definition of it. Like I said, routers will have to know all the remote network, but you can put a default route to tell the router that if you come across any network and that destination network is not found in my routing table, please send it to this particular interface. Okay? I think we will see an example of that command here, maybe, right? Structuring of an IPv4 routing table. The information is indented. You will see they said IPv4 was standardized using the now obsolete classful routing architecture. IPv4 routing table is organized using the same classful structure. Although the lookup process no longer uses classes, okay? So you will have what is a hierarchy there, where you can have a network entry, and that network entry is going to have a child route, and the entry is indented if it's subnet of a classful route ABC. What do they mean by, you have to understand this term, classful and classless route. Classful routes will take a fixed subnet mask, but classless route, you can use any subnet mask information, okay? For instance, a class A address, its classful mask is going to be 255.255.255.0. And class B, its classful mask is going to be 255.255.0.0. Okay? So this is the same thing, the content of the routing table. Okay? All right, this is for IPv6. Like administrative distance, this is also very important. You have to pay attention to this. It's called AD value. A router entry for a specific network address can only appear once in the routing table. However, it is possible that the routing table learns more about the same network from more than one routing source. It is possible for a router, like the example I tried to give you, like if you are at CMIT and you want to go to Westfield, you have different routes. It is possible that a router is informed about a particular destination from different types of route. Let's say, for instance, you can use a static route and a dynamic route to inform a router about a particular destination. Okay? But what happens if a router learns from all this routing protocol? The router is going to take the route that is having the lowest administrative distance. Okay? The lowest administrative distance. For instance, I'll give you this example. If, your close friend should break a particular news to you, a close friend of mine, a very close friend of yours should come to you and break a particular news to you. I believe you will tend to believe that information than hearing, that same information from an unknown person, somebody that you don't know. Guys, hold on, please. Oh, hold on. Hello? Hello? No, Vancouver. Fine. Huh? No, it's wrong. It's a wrong number. Okay? Sorry, guys. If the example I try to give is, if you get an information from a very close friend, like let's say, for instance, Basiru is a close friend of Aminata, and all of a sudden, Aminata went to school and told Basiru that, yesterday somebody was killed in Banjul. I believe Basiru will believe that information because it's coming from a very close friend. than hearing that information from an unknown person. Okay? So that is the essence of administrative distance. Every route has an administrative distance value. Directly connected networks, they have an AD value of 0, okay? And static routes, they will have an AD value of 1. You can see the table here. So in essence, administrative value is the trustworthiness or the believability of a route. Because if you hear information from your friend, you believe that information than from somebody else. That means trustworthiness or believability of a particular route. Okay? So they have values. So the lower the value, the better for that route. So you see the AD value of directly connected network is 0, and the AD value for static route is 1. The AD value for EIGRP is 5. The list goes on. Okay? So static and dynamic routing, I think we are running out of time, so we can just speed up a little bit. Like I told you, static routing is manually configuring, and dynamic routing, routers themselves will send, broadcast messages, information into the router to be able to learn about remote networks. Let's go. Let's see them. Dynamic routing evolution, yeah. Basiru?
Yes, do you have labs in this lesson?
Yes, this is very important. I'll give you lab on this. This is very, very important. I'll give you lab on this, and I'll give you assignment on it. Yes, sir.
If you can please resend me the previous lecture videos. I lost mine because I lost it from my phone. It was in my phone. I think I lost.
Okay, no issues, no issues. Just send me a ping. Just ping me, and then I'll respond to that. So these are different routing protocols.
And I also need them, Mr.
Okay, just send me ping. Yeah. All right. These are different routing protocols, dynamic routing protocols, and their year of evolution. You can see how everything started from 1982, blah blah, up to 2018. So we have, these dynamic routing protocols, they are into 2 main categories. First one is called interior gateway protocol, and the second one is exterior gateway protocol. It's into 2 groups. Under interior gateway protocol, you have a subcategory 2, that is distance vector and link state. Distance vector is RIP version 1, routing information protocol version 2. Sorry, I think for this syllabus now they have removed RIP version 1. So strictly is RIP version 2 and RIP next generation. You also have EIGRP and EIGRP for IPv6. Under link state, you have OSPF version 2 and version 3, ISIS and ISIS for version 6. So for exterior gateway protocols, you have BGP and BGP-MP. BGP is meant for interconnection of different networks on the different administrative domains. Dynamic routing protocol concepts, it dynamically discovers remote networks, like I said. It maintains up-to-date routing information. It chooses also the best path. These are the functions. Okay, and the dynamic routing, it contains, it contains few things like a data structure. It will have a data structure, routing protocol message, and an algorithm. Each of these routing protocol is built based on a particular algorithm. So you will see each of them individually. It also select the best path, like the example I gave you. And they all have a different way of calculating their best path, guys, right? You might believe that, trust me, we all have our different ways of, seeing things. We look at things from different perspectives. If I am from CMIT, I want to go to Brikama. I could go via, Yundum to Brikama. I could go via Java. Basiru might think that Java is the best path based on what? the fare. Maybe Basiru is looking at the cost. Maybe going through Jabang is cheaper. That's why Basiru said Jabang, going through Jabang is the best part. Okay, Aminata might say it's Yundum because of what? Maybe Aminata is using speed. Aminata wants to reach to Brikama very fast, quickly. So to Aminata, I mean, Yundum is the best part. So all this routing protocol will choose their best parts based on their own parameters, okay? So load balancing, that is, how do you take a particular packet and share it? Let's say, for instance, share it among multiple parts so that you can reach to the particular destination quickly. So that is it for all. So I advise you refer to your NETA card, do more reading on this chapter because it's very, very important in your networking career. So like I promised, I'll do a very good lab on this and share with you. And then you can, I also try to give an assignment on this so that you can have hands on yourself. So thank you so much. If you have any queries, this guy is